Right, this is FRQ number 2. Okay, the scenario is there are two trains. Train 1 and 2, they're moving towards each other, then they collide, as shown as seen in the video. So, train 1 is moving at 20 meters per second. At time zero, train 1 is moving at 20 meters per second. And then it's accelerating at 5 meters per second, and it weighs 100 kilograms. At 0 seconds, train 2 is moving at 30 meters per second, with accelerating at 2 meters per second squared, 2 meters per second squared, and weighs 200 kilograms. They're moving in opposite directions, but they're moving towards each other. Uh, and at times they're 1,000 meters apart. So, okay. All right. Um, question part A. At what time will the two trains collide? Um, so they're 1,000 meters apart. Then, so 1,000 meters apart. That is the distance we're covering, 1,000 meters. And then, one way we can do this is to, since the trains are moving towards each other, they're both closing this distance. So what we do is we can do 1/2 at squared plus v it for train 1 plus 1/2 at squared plus vit for train 2. We add these together, and this is train 1, train 2, and their total distance should equal 1,000 since they're 1,000 meters apart. Okay, and then so now we can start just plugging in what we know. So 1,000 is equal to 1/2 a. So we'll do train 1 first. What is train 1's acceleration? 5. 5 divided by 2 is just 2.5 t squared plus vit. What is the initial velocity? 20 meters per second. And then we'll do train, so parentheses that, and then we'll do train 2. What is train 2's acceleration? It's 2 meters per second, and then we'll just do 1/2 times 2 is 1, 1 t squared plus, what is it initially moving at? 30 meters per second. So 30 t, parentheses around that. And then now what we can do is we can combine this. So 2.5 plus 1 is what? Is 3.5 t squared plus 20t and 30t. That is 50t. They should all equal 1,000. And then now we can use quadratic. Minus 1,000. So 1,000 right there. Now let's just put in quadratic equation. So time should equal 11.2075. 11.2075 seconds is the time that both cars will collide. Okay, how much distance did train 1 and 2 travel before collision? Okay, so we can also use displacement formula for this. For this one, so since each train is accelerating, and since each train is accelerating at different speed, and the initial velocity of each train is at different speed, the distance that each train travels is different. So we can't just split this in half and say each train travels 500 meters. That wouldn't be true since each train is traveling at different speeds and accelerating differently. So what we can do is we found the time it takes to hit. So we can just use this time and plug it into displacement formula for each. So 1/2. So this will be train 1. Train 1. This will be train 1. So 1/2 A. Acceleration of train 1 is 5 A T squared. Now we have T squared. We're going to use plug from what we found in part 5 and the part above. Then plus 5 meters per second. I mean, plus 20 meters per second. I mean, within the same time. Oh shoot, I don't got a space. There we go. And now we just solve. So delta x 2.5. Give me a sec. Let me make a load meter. So 2.5 times 11.205 squared, that would equal 314.221 plus 20 times 11.205. 224.15. 224.15. And then we add them together. So now we know that train 1 covers 538.17 meters. Oh, not meters. Not meters per second, just meters. Okay, then now we just do train 2. We're going to use the same concept. Displacement formula. This is delta x of train 1. Train 2 is 1/2. Acceleration of train 2 is 2 meters per second. T squared. 5 squared. Plus 30, put the time again. And now we just solve it out. Let 1/2 times 2 is 1, so 1 times 11.2075 squared is equal to 125.608 plus 30 times 11.2075. 11.2075 is 336.225. And we add those two numbers together. Delta x of train 2, distance the train 2 travels is 461.83. Okay. What is the final velocity of train 1 and train 2 right before collision? Okay, so now that we have distance, what we can use is common form. So VF, okay, let's, this will be train 1. So we'll do train 1 first. What we're going to do is use common form. VF squared minus VI squared is equal to 2A delta X. So what do we have already? We have VI with acceleration, and then we just figured out delta X from part B. So now, so VF squared, and then we'll add VI squared to the other side. So 2 acceleration of train 1 is 5. Delta X of train 1 is, we just figured it out, is 538.17. And then we add plus VI squared. We know VI squared is given. It is, for train 1, it is 20 squared. And then now we can solve. Equal to 10. Give me a second. 2 times 5 is 10. Then 10 times 5, 38. 117 is equal to 5,038. 0.7 plus 20 squared is 400. Oh, you add those two together, we get 571.7 is equal to F squared. We square root both sides. We get the final VF is 76.0374. That is for train 1. Now for train 2, use the same thing. Train 2. So VF squared is equal to 2. Acceleration of train 2 is 2 meters per second. Delta X of train 2, we find out in part B, 461.833. And then we add VI squared, because you know the original equation with BF squared minus VI squared, we add VI squared to the other side. VI of train 2 is 30. Yes, 30. So 30 squared. So 30 squared is 900. Then 4 times 461. Is equal to 1847.32. Now we just add those two numbers together. We get 2,000. 2,747 point, square root both sides. And VF is equal to 52.414, right? For final velocity of train 2. Okay, part D. What is the total mechanical energy of the system at the moment right before collision? Okay, so it's asking mechanical energy of the system. So first, we need to identify what is the system. The system is the two trains moving towards each other. So mechanical energy will be adding ME1 of train 1 and plus ME1 of train 2 is equal to the mechanical energy of the entire system. So then, what is mechanical energy then? So mechanical energy, we know, is just equal to PE plus KE plus KE. Let me write a little bit neater. Plus KE. But in this scenario, we don't have a PE because there's no height. All we have is a KE. So in this scenario, ME is just equal to, we cross off PE, it's just equal to KE. So now, what is KE? That's simple. We can just 1/2 mv one half mv squared. So that's fine. Mechanical energy of the first train, 1/2. What is the mass of the first train? We're given it as 100 kilograms. V squared was the velocity of the first train. However, remember what's asking us. What is the total mechanical energy of the system at the moment right before collision? Therefore, we can't use the initial velocity. That would be wrong. We have to use the velocity at the moment right before collision, which is the final velocity. And what did we just find in part C? The final velocity. So we find train 1 final velocity in part C. It is 76.0374. So 0.03. I'll just round it to 0.3. I'll just round it to 0.37 squared. 1/2 mv squared. And then now we just solve. So 1/2 times 100 is 50. 50, and then 76 squared is 5781.7 is equal to ME1. Multiply these two numbers together. We get ME1 is equal to 289.085. All right, and then now we just need to do it for train 2. So for ME2 is equal to what we derived from earlier, 1/2 mv squared. So 1/2 mass of train 2 is 200 kilograms. Velocity of train 2, final velocity of train 2, excuse me, it is 52.414 squared. And now just solve it out. 1/2 times 200 is 100 times square 52.414 squared is 2747.2. Then we know ME2 is equal to, multiply those two together, 2747.733.2. And then now, since the question is asked for ME of the system, we need to add ME1 plus ME2. So we add 289.085 plus 274,733.2, and we get 563,818.2. Let me rewrite that real quick. this all is equal to 563818 18.2. This is equal to the ME system. There we go. Okay, and then part E. After the collision, the two trains stick together, then both move in the same direction together. What is the velocity after the collision? Okay, so what happened here is the two trains hit and stick together, which is an inelastic equation. And for inelastic, and it's asking for the velocity of the collision afterward. We know the inelastic collisions. The formula for that is mv plus mv is equal to m plus m v. Well, mass 1, mass 2, mass 2 is equal, and then they share the same velocity. So first we need to figure out the momentum of train 1. Mass of train 1 was 100 kilograms. And remember, the velocity, when it's referring to velocity, since this is we're looking at the train during its collision, but right before its collision and after its collision, we have to look at the final velocity right before the collision, which is also the initial velocity. In this, I mean, in this velocity right here is actually the final velocity right before collision. So we can't get it confused with the initial velocity at the beginning. So 100, and then the velocity we figured out earlier. Yeah. This is I. This is I. 100. The velocity we figured out in part C for train 1 is 76.307. And then for train 2 is 200 kilograms. A lot of velocity for train 2. The velocity right before collision is 52.4. It's 52.414. And then if we solve this, 100 times 76.307 is equal to 730.7 plus 100 times 52.414 is equal to 1,482.8 is equal to, if we add up M1 and M2 from up here, we get 300. And then VF is what we're trying to find. Okay, so then we add the left side again. We get 18113.5 is equal to 300 VF. Then we divide by 300. Then we end with a VF. For final velocity after the collision as 60.378.